I'm not going to talk about
All right, let's go ahead and go to Desmos. And then I don't know if I just go to Desmos if it's going to give me the geometry one. So we have to go to desmos.com and then /geometry. It's on your notes. It's next to the shift button by the, it's a question mark.
Slash what?
Geometry.
Geometry.
Metry.
You don't sure if it's geometry?
Hey, Mr. McConnell, what is a
Brody doesn't move very.
what is a simple?
We're going to talk about that.
I didn't spell geometry right.
So
Hey, you can
this is 10-4, yes. All right, so, excuse me. So we're going to do this together. My notes don't, basically I wrote this for myself for next year, so don't give it too much attention. So basically what we need to do is to make a circle. So we click on the circle, and to make a circle, it gives you a point, that point that is the center, and then boom. Make it so it's not, off the screen. One thing I want to point out is once you click on the, I kept messing this up yesterday. I was like, oh, I want to change the size of my circle, which would be clicking on this. But yes, if you're in circle until you get out of circle. So yesterday I had circle death because I was like, okay. There is an undo button over here, which I was glad to find.
And then I made more circles because I missed the undo button.
So if you go to select, then you can kind of move. You can move your circle or whatever and make it the size you want. Okay. Then I want to inscribe an angle. Let me tell you what makes an angle inscribed. Sure. What's going to make the an angle inscribed?
I don't think any of us are actually okay.
Can I draw attention to what you're doing? Yeah? She was trying to shut that blind. But what do you guys notice about it?
It looks better.
Oh,
You have to turn the thing.
It's already pulled up. It's pulled, okay. Anyways, so here's an inscribed circle. The vertex. Just let it go. The vertex. Why do I feel like no one's listening to me? Sad face.
The vertex. That's all you said.
Oh.
Say more.
Okay. The vertex must be on the circle. That's how you make an inscribed circle. So I'm going to take a segment and I'm going to touch the circle somewhere and I'm going to touch it somewhere else. I just made a what? No.
The chord.
I made a chord. I want to now create an angle by connecting two chords together. This is an inscribed angle because the vertex, which is right here, because the vertex is touching the circle and the angle's inside. We're going to do that. Okay. So I want to know what is the measurement of this angle. So I hit this angle button. Am I going too fast? How'd I do what?
Can you just rewind a little bit?
Okay, so I made two segments. I hit the segment button. I made one here, and then I chose the same point, and I made one here.
Mine's 58.
So it included angle just
Mr. McConnell, I've already done.
The vertex has to be, yes, two chords where the vertex is on the circle.
What if it's not completely like perfect? Mine's 27.
So I've been kind of asked,
How do I find them?
she said, is it two chords meeting? And the answer to that question is, so why is this not an inscribed circle up here?
Because it only hits one point thing.
Because the vertex needs to be where?
At the end.
On the circle, not the center, but on the circle. Anybody know what this angle is called?
That is a central angle.
This is a central angle. Why is it a central angle?
Because it's 360 degrees.
Because the angle is in the center of the circle.
But would it be 360? No.
Dalton, did you hear that? Because you asked that question.
I already did, I'm just thinking, I did.
Look up here. This is a central angle because the angle is in the center. This is not inscribed. This is not what we're talking about. But if I could, I would write on it and say central angle, but I don't know how to do that. Okay. So finding the angle, I got to push. Yesterday I did all kinds of bad things, but to name an angle, you go 1, 2, 3. So that's how you find the degrees of an angle. Boom.
Mine's 46. Does that matter?
Doesn't matter. I want them all to be different because we're going to show. So I think geometry is pretty cool because every now and then you learn something and go, wow, that's crazy that always works that way. If you have an inscribed angle, we want to compare it to its central angle. So on the same circle, I'm now going to draw a central circle or central angle.
Okay.
So a central angle means I'm using the same points, but instead I'm going to the center. That is a central angle I just created.
It's twice the amount.
Exactly double.
No, wait.
Mine's not.
What
What am I doing?
So I now have an inscribed circle and a central circle, or central angle. I keep saying the wrong word. Sorry. Using the same, what would you call these? I think they call them legs. I didn't like that vocab, but the legs. And it's double.
Wait a second. Is 93 double 46?
46.
It should be 92, I thought.
Mine's not.
Mine
should be 114, but mine's
It's probably not double zero again, so
Mine's-
probably.
Mine's one off.
I don't know what I'm doing.
Mine is
Liar, liar,
Buddy,
liar.
I will use this piece of paper.
Hold on. Now, the only reason I could think that it would be off is if your points are just a little bit off from each other.
You were supposed to make a point.
So the crucial point, the crucial thing is that these points have to be the same
How
for
do we
both.
make them the same?
I don't know. It should kind of force you to have done that.
Exactly, but mine-
It didn't force me to do it, it just let me do it.
Okay. So if you zoomed in here, I don't even know if we can zoom in, but if we zoomed in there, the question is, are those the same point? Now, it should be super close to double, okay? But the central angle and the inscribed angle is double. And this kind of blew my mind last night, that you can now use the select tool. And no matter where I put this point right here, this point, as long as I keep that on the circle, what is this angle going to be? It's going to be the same. I can move this wherever I want, and it's not, oh, except if I go over there. Actually, if I go over there, what did it do?
It went to the 153, which is like on that one, 125.
It made a diamond.
Yeah.
Well, it's the angle of half of this. Okay, so no matter where you put this, so an inscribed angle, in the book they say, look up here for just a second. Look up here, please, everyone. Look, not at me at the screen. You scared me. inscribed circle, the key is the vertex is on the inscribed angle, excuse me. The key is that the vertex is on the circle. Look up the screen. So it's weird because you can see that the center point doesn't necessarily even have to be between inside the angle, okay? It doesn't matter as long as this vertex. It's even weird because what if I make this point and that point the same? Still works. What would that mean if those 2 points are the same?
And it's
They're both the segment.
It means it makes a tangent line across this way if these 2 points are the same. Okay? It still works. Okay? So it's like this part of the ray or part of this is shooting out that way. So here, let me make it the same. So you have
Oh, that's a tangent.
and that's our tangent line. So you can't see the other part, okay? Because they're touching each other. But if you have a line, a segment where the points are the same, that's a segment with 1 point. Okay. Do you understand? Okay. I did a great job
So you
explaining that.
have tangent segment.
Thank you.
Good job. It looks like a
If I move this line, or if I move this point, the numbers do change, and it should always be, this is double that.
Yeah, mine's still off by one, but.
Okay. So I'm not sure why that happened. Okay. So basically, we have to realize that if we have this angle as the question, we look across for what the central angle is. Also, I want to remind you, and I did not explain this that way fully. Sometimes we can write 133 there, but where else might they write 133 for that angle? Yeah. Sorry, she stole your thunder.
Wow, man.
So they might write 133 here. They call that the arc. Okay, so it, right where my cursor is. Remember how they would write it out there? Yep. Any questions on this? Sure. So I think it's pretty interesting that forces that to happen if it's in the circle. No matter what, you can make the circle bigger. It doesn't matter. You can move things. It's still always double. You can distort it, like make it weird looking, and it's still half of those points. Okay. What'd you say?
What? Nothing.
If I make it 180, that makes this angle here what?
No. There was something else. You can make 0 degrees on it.
On this?
Yeah, you have to do
Yeah, that you can do that.
that. Deleted.
So it's rounding, right?
No, it goes 0, 0.
But right there, it's rounding.
But it could go.
Okay.
yeah, if you make it a straight line.
There we go.
Yeah, how big are those angles? And what's double of 0?
0.
Oh, wow.
And what's 0 is not a 0.
Well, see,
Cookie Monster? I don't know. So 0, 1, I'm saying it's rounding. It's rounding down or whatever. Okay. So actually, I think once, and really geometry loves to give you very straightforward rules and then just throw a ton of extra information, and that's how they make it hard. Okay. So if we start with number 1 here, it says that the measure of the arc is 47. So they're telling me that this right here is 47, which also means the central angle is what? So Dalton, you know what the central angle is now?
Yeah.
So that's the central angle. We don't actually have to write it, but that's what they're telling me. So then they want to know what is the measure of this angle here, S. The measure of angle S is
No, it's
23.5.
Yeah.
23.5. So be careful that you don't go the wrong way. Okay. The central angle is twice as big, so that means the inscribed angle is half its size.
Find that again, please.
Yes. We have two angles, right? So I didn't draw, I kind of drew it, but not very good. So we have this central angle
Why does that central?
because this when they tell you that the arc here is 47, they're giving you that degree of that central angle. It's not the length, yeah. So I think when they don't give you the M, it's the arc length. Okay. So we took 47 and we knew this was a smaller one. It's half the size. He took 47 and divided by 2. So the next one, they're going to get tricky with us. They're going to say RST. So right here. And the way they get tricky is they give us a bunch of stuff at once. But RST corresponds to this angle right here. 164 is the central angle. I kind of don't want to draw it just because it's already a mess. So then what is the measure of angle RVT?
RBT, or wait, hold on. What is it? RBT?
RVT, is that, did I say it wrong?
It's 84 divided by 2.
So it's 82.
I did.
They could, if just to mess with you, if they had asked you the central angle, okay, you would have to say that it was 164. And then they give us, then they tell me the SPU, and we go in the order that it gives us. So I got to go SPU is 79. I like what they did here.
How do you know which one is the central angle?
Say again.
How do you know which one is the
They're all the central angle.
What?
So when they give it to you on the outside, this is the same as the central angle. Okay. So this one's central angle is 79, but they did something weird.
No, it's double.
Yeah.
You gave us the angle, we need to measure.
Yeah, so
not the arc.
75,
Yeah.
79
Oh.
times 2.
Oh, I did that wrong. I'm sorry.
It's 158.
They gave us this.
Yeah.
They gave us that this is 79. Did that completely wrong. Sorry. Hey, look, I wrote in pencil. Just kidding. It was never there. And then they want STU. I even wrote that thing wrong. Okay. So the measure of STU, or the arc, is
158.
158. Be nice.
No, you did like, I was trying to.
Good job, Brody.
You sound like Mr. Day to me right now. Mr. Day's always like,
Oh, yeah.
Oh.
trying to get me to like mix up my words.
What, are you attacking me now?
Yes.
Why are you coming at my neck?
That's what Mr. Day says.
He says you're attacking me?
Yes. So Mr. Day
I
says,
like
why are you
Mr.
attacking
Day.
me? But he always talks about how he wants to punch us.
There's a video you're gonna watch today.
All right, so let's keep going.
It makes you want to punch him.
No. Let's not talk. We're recording this, so
Woo!
That's why I said I like
Let's just send this to Mr. Day.
Hey, Brody, how would you feel
if you sent this to Mr. Day?
given that BD is tangent to P, when I tell you that a segment or a line is tangent, it means it's 90 degrees to the center, to the radius. They didn't draw that. That means that that's 90 degrees. I don't know what that's going to do for me, but they told us that. If the measure of arc AC, so here to here is 88 degrees. What is the angle of ACB?
90 minus 88.
How would we?
What?
What?
44. 90 minus 44.
Isn't it just 88?
Isn't it 90 minus 44? No. Yeah, no. Yeah, Mr. McConnell.
So they want this angle right here. Now, this is that case where I was trying to tell you that it's really weird. This is an inscribed angle. BCA is inscribed because C is where?
On the thingy thing.
On the vertex. If C is on the vertex, it's an inscribed angle. So then what you do is you go across from it and you say, what is this angle here?
88.
So you do what to it?
Divided by 2. No. 44.
Yes,
Get
44.
what?
To get this angle right here, BCA.
Well, Rachel, it's gonna have to get
But isn't 88 the measure
44.
AC?
That is the central angle
It's the arc.
is 88.
What the heck? This is too confusing.
Yeah, I don't get
Don't
any of
get
this.
any of it.
Get my brain.
Okay.
Like my
Like
brain.
mark over the 88.
Well, then it works. That's just it. Yeah.
Do what now?
Just mark over the 88. I just know the center.
So that's 88 is the center angle. So that means this angle, which is on the vertex and hits the points,
Okay.
is that. It's really kind of weird because
It
the,
bugs me when it's on the outside, because I think it's the angle between.
right, it's weird when it's a tangent line because, so the fact that this met at 90 degrees meant nothing. It just meant that the vertex and one of the leg points is the same, which is weird. Okay, so let's look at this one. EG is a tangent to P if G, the measure of angle GFC, this angle right here, is 115 degrees, then what is FAC?
Hey, watch
That's angle A, right? So now is that 44 or is that 88?
So when it's an arc, it's the central angle.
It's just, yes, they're giving you the central angle. It's just another way of doing it.
It's whatever that
They're
is.
writing
divided
your
by
name,
2.
Bertie, but they
Yeah.
forgot some of the
Which
digits.
is 57.5.
They're writing your name, they just forgot some.
I don't know how you're going to feel about this, but it's 230 degrees.
I agree.
Oh,
They're missing some of the G.
I'm puzzled.
Oh.
You have to double it. I get it.
That's so funny.
Okay, never mind. You have to double it.
Okay,
Isn't that
'cause
the inside angle?
This is the angle, and then they want, guys, no. They want the arc, okay? They want the arc, and the arc is the same as the central angle
So if we have an inside angle, we have to multiply that.
by 2 to get the arc.
Not
So you can
divide.
kind of think of the curved angle as the arc angle, but also that is the central angle. Those mean the same thing. So I kind of expected this to be somewhat confused at this point, so we're going to draw out what the rules are. Okay? So imagine we have a point in the center. Okay?
Do we draw a point in the center of
Yep,
all of them?
just draw. No, let's just do them one at a time, whatever I do. So the nice easy one is if we have this. Let's go ahead and put angle 1. And then if I can just put a 2 out there. Should I use letters or numbers?
Numbers.
I
Okay.
don't like letters.
Do you connect those? to
So
the-
that means that angle 2 is equal to 2 times angle 1.
But don't we need to connect it for that?
No, we don't have to do anything.
Isn't that telling us that 2 is equal to 1?
Where?
No, it says 2 is equal to 2 times angle 1.
Well, why are we putting angle 2 arc? That makes no sense.
Because this is the arc. To measure that arc.
It's not an angle though. Is it an arc or an angle?
Oh, I'm sorry.
The arc.
You're right. This should be an M.
It's just saying like the measure
Excuse
of
me,
that arc,
excuse
that
me,
is the
Maddie.
arc right there. Saying the measure of that is twice the angle.
And you might say it the other way, that angle 1 equals half of 2.
So is 2 just talking about from the center point?
Okay, so the central angle, this is a side note. If I tell you that this equals 52,
Yeah.
okay, then I also could write out here 52.
Right.
So I would say, in this case, I would say central angle equals 52 degrees, or I would say that arc, I don't have a name for it, arc AB equals 52. Those mean the same thing.
I understand that.
Okay.
But I'm talking about, is this still talking about where we draw the points from the corners to the center?
We don't have to draw the points except in our minds.
Okay, so that's what we are doing.
Yes, I'm sorry, yes.
Okay.
Wait, can you move it down a little?
You like hairs in the way.
Yep.
So maybe life would be a little easier instead of drawing vague things. We got a central thing. Let's draw like a weird one. So looking at this, somebody tell me what this angle roughly looks like. Give me a number.
30.
Okay, so 30 is fine, I guess. If that's 30 degrees, that angle, then this arc, this is 60.
60 degrees or 60 length?
60 degrees, but they don't put the degree mark on there.
What does that stand for though? Does it stand for the middle arm?
That's, yeah, okay, so go back to this, guys. These mean the same thing.
Right.
So if I put 52 out here, they call that the arc degree, and they actually don't even the measure of the arc. If I make an arc all the way around, it's what? 360. So they're telling me that this is 52. Or they can write it here or here. So
Well, when do you actually know that it's an arc?
they don't put this on there.
Oh.
Okay. So yes, that is really confusing because they don't put the degree mark on that.
Okay, next circle.
So what if we have it actually going through the center? I don't know. Let's make it kind of weird like that. What angle does that look like?
78.
No, 82. 82.
No.
Fine, 73.
That's not anywhere near 90 degrees.
73.
It's 63. So if there's a middle,
18.
It's up there.
Let's just 73.
63. I could ask two questions. I could ask, what's the central angle? I could ask, what's the measure of the arc? And the answer would be what? This is 126. If I ask, so the arc is 126. If I ask for the central angle, it's what?
180.
It's the same. This number here is the same as the central angle.
Oh, yeah.
If you look, you better have this written down on your paper. I'm going to start flipping tables.
That's what
I'm
they
gonna
said.
I'm a day on you,
I know.
all day on you.
Let me copy it.
I know it is. They're the ones.
well, some of us don't quite understand.
No, but like you don't let me to write when I know it.
You don't.
Listen,
Yes,
you coming at me again?
You're the one who's questioning everything.
Like,
Rachel.
I
he's
did it.
not Mr. Machado, Mr. Day.
No,
like,
you
he's
don't.
like ranting, like he's not ranting, but he's like saying stuff.
He's
He's like, yeah, if I want to, I just backhand Brody. I'm like,
Why me?
You know why he says that?
Once a month,
'Cause you can
he
take
just
it.
slams the door and he's like, "You gotta talk. Everyone here needs to get a job soon, And I'm gonna
Make
not waste
sure
my
you
time
know the
teaching
3
you.
branches of government so you can get a job at McDonald's.
Yeah.
What?
He's like, you guys are so lazy.
Most.
I
Yeah.
spent my reading this whole class today to
Huh?
get done everything I
No.
got. I'm not.
All right. So going back to number 2, you said? Okay.
Is 60 the central angle, even though it doesn't have to be the central point?
Yes. So 60 is the central angle. Let's go ahead and close Chromebooks
Okay.
because you seem distracted by them. What's up, man? You're what? So even though it's not drawn, if I were to connect this and this, the angle I just made in pencil is what degrees?
Okay.
60 degrees.
So is the outside number always a central angle?
Yes. That's another place where they write it. It has this, it means the same thing, it just is said differently.
Are there any exceptions to that? Because I know there's always.
So the thing we don't like about it is it's confusing. Is this talking about the angle or is it talking about how long that arc is? So the notation is slightly different. If they tell you the measure of the arc, they're talking about degrees. They're going to say it very differently if they're talking about how long this is. It'll probably, here's the huge key, is if I put inches on there, then that means they're talking about how long is that. But if they don't, they put nothing on it, it indicates that that's the central angle. You need the central angle for these. You don't need to draw it, but you need to know what the relation is. Okay? I'm going to take some responsibility because I thought we had talked about the central angle, but I'm not sure I made it super clear. The last picture we're going to draw is probably the most confusing one. I'm going to put a vertex right here, and the center point doesn't really matter, but I'm going to put my vertex there. I'm going to put one part going this way, and I'm going to put the other part as a tangent line going that way.
I don't like that.
You can. It doesn't do anything for us. So if I tell you that this arc length right here is, what would that be? That looks like it's about 87, 88. Then even though this angle is really weird because the tangent line, this point right here is both the vertex and the leg line because it kind of just shoots out. This is considered inscribed even though only kind of half of it's hanging in there. It's like infinitely small inside there because it's hitting at how many points? 1. So the vertex and the leg are the same point. That's what makes this happen. It still follows this rule that this angle right here is what?
44. Oh.
Is 44.
So even though 88 is written in the middle of the angle, that's still for the central angle and not the angle it's written in the middle of.
Inscribed angles are half of the central angle or are half of the measure arc.
So let's say you have that circle thingy, and the 88 instead is for the measure that's now 44. Where would you write it if they're giving us that?
Okay, so let's just create a new problem down here. So tell me what you want me to draw the same picture?
Yeah.
Draw the same picture. So I have a chord and I have an inscribed angle even though it is tangent. Okay.
Okay.
And you want me to say that this angle here is what? Is that what you're saying?
That, I I'm saying, like, what would you write if that angle was 88?
So if that was given, it couldn't be 88 because this angle is no way is it 88. Let's call it
42.
let's call it 42. So the questions they could ask is, what's the central angle?
So it has to be right on the arc to be the middle, to be that angle.
How do they identify that angle?
Yeah, I'm saying, like, if we,
Like, how do I not know that this is the angle or if that's the arc? Is that what you're asking?
Yeah.
Okay. So how I know that this is the arc is placement, right? Oh, I'm sorry.
oh no, I'm just talking about, I thought 88 was the angle because it's in the middle of the two sides.
Okay.
How do we know that that's not?
We've talked about this a bunch. We've talked about this. We're still confused. Okay, so here's another example of what you're talking about. If I give you this drawing and I put 4 right here, then 4 is the what?
Radius.
The radius. If I had not put 4 there, but I put 4 there, then 4 is the diameter. If I give you an angle, if I give you a circle, right, and inscribed, and say it's crowded. If I want to give you the angle of the inscribed angle, I better write it really close to right here.
Okay, that's what I was.
If I want to give you this part, then I'll write it right in the middle here.
Okay.
Okay. Good question. Because if it does get crowded, then you need to know where things are. And they do a good job. Okay. So on this one, and this one's kind of weird to me because sometimes I've seen where they don't give you the degree, but this one they're giving you the degree. Okay. So 196 is what two things? It's the central angle and it's the arc length. So you could say that this right here is 196 degrees, or you could say that the central angle is 196. It means the same thing.
So is the arc 196 units long, or is it just saying that the angle that the arc is talking about is 196?
What it's saying is a circle has 360 degrees.
Yeah.
We're taking up 196 of them.
Okay.
And then that's another 50, so you just figure out the other one.
So if I said 180, then
It would be half the circle.
it'd be half the circle. Yes.
Okay.
Good. I think I might be teaching today.
You made it make sense.
Okay. Woo! Someone give me a raise. Thank you. Good job, Miss McCollum. Really? No, I only get one person clapping and myself. Tip jar will be at the door. Okay.
Can you break it 32?
Yeah, can you break it?
Yeah, can you break it 20 because he has 3?
So this is asking for the measure of this. No, I lied. It's this way. Sorry. That is the same thing, guys. That is the same. That is the same thing as the central angle, but they want to know this, basically the angle. How much of 360 is that part of the circle? I see it right now. Does anyone else see what it is? What this red arc, how much of the circle of this is? It's 100.
Because 50 times 2
50 times 2.
Oh, I thought we were still talking about length.
Because we have this angle right here, and even though that's weird because that angle is just like slightly on the circle, it's still inscribed. So you go across from it and double it. Yeah.
So, okay, just 2 things. One, just to make sure I'm getting it right. So then, since that is the angle, that means that that's the inscribed angle. So that means that whatever that is double that is the central angle and that arc length, right?
Mm-hmm.
So if that's 100 and then ZV is 196, and that means right there that'd be 104, right? The XV.
You're getting ahead of me. So you're asking, okay, so you're asking me what is this right here? Not the angle, but the arc.
It'd be 360 minus 196 minus
100.
Which equals what?
a number.
64, and then you divide it by 2.
Or, yeah, never mind.
Why would you divide it by 7?
Because the next question is asking what
Just you do want the
BSW
angle,
is.
not the angle, not the arc.
It would be 32.
I'm yelling.
Yell.
Okay, so we know that the Jonathan, can you stop that? We know that the circle is going to add up to 360. All the numbers on the outside have to add up to 360. We just found this one as 100. Okay, we know this is 196. This is what's left over. So 360 minus these two is 64. Then to figure out the angle that's across from it, the central angle, where the vertex is on the circle, we cut it in half, we get 32.
That's what I thought it was. I'm so proud of myself.
Then you should just subtract.
You could have done 180 minus 50 minus half of whatever that is. Right? What is this angle right here? It didn't ask for it, but what is that?
196 divided by 2.
Yes.
What angle?
Have you found that these worksheets are easier or harder than the online stuff?
It depends on the week.
I think they're super straightforward.
Yeah, these are straightforward.
Yeah.
And easier to do it, easier to
Please write on here that this is 10-4. 10-4 quiz.
My uncle used to be a truck driver. I asked him to do something.
The key is the vertex has to be on the circle.
What's the difference between inscribed